Hi everyone, this is another AC community event. I'm so excited for the guest that we have today. This is Samane Zolfagarian. I'm leading this community for a while and we are 3 minutes late because of a technical issue. So that's the fun part of every live event. And I'd like to introduce Eric Lott, the CEO and co-founder of Urban Machine. Eric, so excited to have you here. Thank you so much for your time. And
it's a pleasure to be on, Samana. Thank you very much for having me, and looking forward to a great discussion about salvaging lumber and technology.
thank you. Do you mind to introduce yourself for like 2 minutes, 3 minutes? Tell us like what you do and a little bit about Urban Machine.
Yeah, absolutely. So we are a 1.5-year-old robotics startup that is cleaning up reclaimed lumber so it can be used to build again. Every year in the United States, about 37 million tons of dimensional lumber heads to our landfills or incinerators. And what we want to do is we want to recover that material, and our robotics remove all the metal from it. And once it's metal free, then it can be used to build furniture, buildings, the same things that virgin lumber do, except for our material is higher quality because it's much older, drier, higher quality wood that isn't harvested today. And my background is I've got about 20 years of construction and technology experience. Sometimes I've merged those two together, like in this particular application. And we're a team of 8 based out of Oakland, California.
Great, thank you. So you a little bit touch on the waste management and how Urban Machine can help with sustainability. I'm curious to know like why you started Urban Machine. What was the main motivation behind it? If there is any fun story, or it was like tell us a little bit about that.
Yeah, absolutely. So previously, I was at Swinnerton, where I built their innovation program, and we focused on bringing robotics into construction. So we're solving the labor shortage problem that we had by augmenting folks with robotics. And so I got to spend some time with a lot of startups there, learning about robotic capabilities, using computer vision and AI for field identification. And I also got engaged with the sustainability initiative, where we're researching waste streams coming off of our job sites. And that's where I learned about, concrete and steel have recycle paths, but unfortunately wood did not. The majority of wood was going to landfills and incinerators. A little bit turns into kind of mulch, a downcycled material. But overall, it doesn't get reused. And when we look at the numbers and the volume, it's a massive problem. Wood is one of the largest contributors to landfill waste coming out of the construction and demolition streams. And it's a beautiful material. We were doing a lot of construction with our mass timber group, building these wood buildings using all virgin. And it's like, wait, why don't we use something we've already got? And so that's where I reached out to Andrew Gillies, my co-founder. He and I had done some construction research on other robotics applications. And he's like, oh yeah, we can totally automate this. And the great thing is this is a problem that's not being solved by humans today. So we're actually developing a new industry and bringing people to work to solve a problem using technology that's not really solvable with just people.
Great, thank you. So you discuss about concrete, but my assumption is your focus is just on timber. So you try to resell and their reclaimed timber. This is like a common process in developing countries. They try to resell like building products after demolition. However, in developed developing developed countries, it could be different. I'm just curious how the US market reacted to this idea, and like what's the process of adopting this new culture, and even if you see it as a new culture.
Yeah, absolutely. So everybody loves it. Everybody loves the idea of reusing wood because you're not just reusing a material, but you can actually carry the story of that material with it. The great part about our project is we're not just recycling it, but we can keep tabs on where that material came from. So imagine walking into a new building and you see a QR code on the wall on a wood timber, and you hit it with your phone and it brings up a web page that shows you where that piece of wood came from. Hey, it was originally came out of this particular mill, 60 years ago. It was in this building for the last 50 years. That building was torn down, and now here it is today in your new office building or your new condo. And it's got that warm quality to it, right? Concrete and steel have got great structural properties, but when it comes to warmth and environment, they don't do so well compared to the wood material. And that's the cool thing about this project is we're not just solving an environmental problem, but we're also providing aesthetics and design and warmth and touching on that human element with it. And the great part is this material is incredibly high quality. It's something you can't find in the forest today, much higher quality than you could ever buy at a lumber mill today.
That's a great point about the quality. So I'm just curious if it matters in terms of which region you supply those timber materials, or it's like in general, like is there any policy or rules behind it to validate the quality?
Mm-hmm. Yeah, so the quality is pretty consistent across the globe, right? When we in the early 1900s, we were logging much higher quality, older growth trees, no matter where you were in the world. Those trees have been growing for hundreds of years, whereas today most of the stuff's coming off of tree farms, where their age is somewhere between 20 and 50 years, depending on the species and location. And so it's a much smaller lumber product that's growing much faster, so you get less quality. And really, the only thing that changes with regions is the building material choice. Typically when you get down around the equator, it's a lot more concrete and steel because there's a lot less softwood strength lumber available. But where you get away from that, into North America, Northern Europe, you get a lot more solid woods, the softwood markets. And all those markets have the same challenge. Over the last 100 plus years, we've built a lot of buildings with wood before steel and concrete came on the scenes. And those buildings are aging out. And in the US, we cycle our buildings faster than anywhere else in the world. And so we need to reuse that material. And so when it comes to structural reuse, the states of Oregon and Washington are leading. They both allow reclaimed dimensional lumber to automatically be treated as a number 2. So you don't have to actually get a grader out. The rest of the US, we just have to get a grader on site to come out and do a visual inspection on the material and provide a grade for that batch of material. So it's completely reusable in structural applications, architectural applications. It can go right back into buildings after it completes an inspection.
Interesting. Great. So you do some inspection for the quality of the material.
Mm-hmm. Nice. And in our process, we do cameras, we do visual inspections on the material. We're also going to be introducing an X-ray, so we can actually look inside the material to check for any hidden decay, any hidden cracks in the larger timbers. And we're going to be reclaiming not just solid lumber, but we're also going after the engineered glue lamp product. So that's another large structural member that we're working on a reclamation process for, because it's a really high value product that should continue to serve in new buildings after the previous one comes down.
And how do you find your suppliers? So because I see like many opportunities in terms of finding those demolished buildings, the question is like how to get in touch with them, how let them know that there is Urban Machine who can help you with recycling your timbers and helping the environment, helping the economy.
Absolutely. So there's 2 main sources. We work primarily with demolition contractors on your large commercial industrial buildings, because with those, our machines are actually portable. So when they roll out here in a couple months, they'll be on trailers, so we can actually go to the job site and do the cleaning directly at the job site. And that's our preferred method because we're as close to the source as possible. So we get the highest quality material, we can maximize the volume of material that we recover, and it reduces the environmental impact because we're not hauling around dump trucks full of lumber from those job sites. And then once we clean it from there, we can put on flatbed trucks and maximize shipping to wood fabricators, wood manufacturers, whoever the customer is for that particular batch of lumber. The second customer site that we'll be working at is what we call collection points, which are typically C&D transfer stations. So that's usually where your smaller contractors are taking their trucks and the pickup trucks and dumping off your residential loads, small commercial industrial loads. And so we'll be operating there to separate the materials out of their waste streams and recover them at those facilities, and then clean them up and then ship them from there to the customer. Our goal is to try and recover wood within 100 miles of source to destination, full life cycle. Whereas traditional virgin lumber is running 1,000 to 2,000 miles on their supply chain. So not only a dramatically more sustainable product, but also the supply chain carbon is much smaller footprint with reclaimed lumber.
Fantastic. I'm really curious, and I'm not sure if you have any factory tour. I can't wait to see your factory, and robots are doing all like renovation at the factory. I'm just curious, like, what's the process? Like getting timbers from the site, shipping to the to your factory, and trying to rebuild them, convert them into a new timber look. Like, what's the process?
What's the process? Well, let's add some video to it. Let me share my screen here.
Awesome.
Do a little video as I talk through it. This way the audience can actually see what we're doing. So right now our machines are still under, kill the music there. Our machines are still under development. So this is actually our third engineering proof of concept that we're showing here. And this is where we prove it out at full size. We can clean the lumber. So the great part is we're not actually grinding it up and converting it to some new engineered product. All we're doing is removing the metal because the strength to wood is its fibers. That's what gives it the high tensile strength and capabilities to be a structural component is the fibers. And so we want to keep those intact, right? We want to minimize any re-engineering or remanufacturing of the product. And so what we do is we have an in-feed station where the forklifts and the crews load the material into the machine. And then we have a human operation to remove what we call the big ugly fasteners. Think like big structural brackets and electrical boxes. And then we start a light cleaning process with these brushes where we take off any surface contaminants. This is light dust and dirt. And the other thing we're doing too is we're shining up the nails. We take a little bit of rust off of them. And that helps us with our cameras. Because here in the picking cell, we're using depth sensing cameras to take pictures of the lumber with the nails. And then we remove those fasteners using a point cloud in those photos with the end effectors here. And the great thing is it's a beautiful product. So this was a project that one of our interns built, a bookcase, and it's all built out of reclaimed lumber. So it's reclaimed glulam on the sides and then reclaimed solid Doug fir. There is the partition pieces. So it's a beautiful product that we're cleaning. When you take that outside layer off of it, it comes out really nice. And it's all done with robotics. That's the cool thing. So you'll see here. So here's one of our pickers for removing the nails and the staples and the screws from the lumber.
That's awesome. The point that I missed when looking at every machine was like, you can use those timbers and convert them into even furniture. Like you don't need new timbers. It's just more than just building houses.
Yep, absolutely. The biggest market is going to be the building space, right? Because the volume of lumber consumed in buildings far exceeds that of furniture. So that'll be our biggest customer base, is getting it back into buildings. We think prefab's a great opportunity, CLT is a great opportunity for reclaimed lumber, and then the furniture folks are really the three main categories where we see this material going.
Great, awesome. So you touched a little bit on like sensors that you use on depth. You mentioned depth sensing cameras. Like how AI is involved in that process, and what was the outcome of using AI? Like how it expedite your process, or like how it is helping you?
Yeah, so AI is actually solving the problem. So the cameras take pictures of the wood. We create a 3D point cloud using the images from those cameras. There's two of them in each cell. And what we do with that point cloud is then we go through with our AI and we scan it to identify where the nails are and the staples and the screws. So we have to determine the type of contaminant. We have to determine the location, and then we use the orientation to determine the pick plan. So how are we actually going to go and grab that? What's the best orientation for the robot end effector and which end effector? And so we've been training our algorithm by scanning, thousands of pieces of lumber running through our system to build our data set. to teach the AI algorithm, what does a nail look like? What do all these different nails look like, right? Because you got everything from finished nails on up to, the big 16 penny framing nails. And then you got all the different screws, you got all the different staples, all these small fasteners that we're going after. And so we train our software on those different fasteners and what they look like, their orientations, and then what's the best pick option for pulling those particular fasteners from the lumber.
Wow, that's amazing. And it looks like that your AI model that you're training is helping you with like finding it, the type of the metal, and then even picking it up, removing it through the process.
Exactly.
It makes me ask that was there any funny story that you tell the robot, why you did that? Like why you removed this part?
Yeah, so one of our challenges has been small knots and nail heads. So if you have a flush nail head in the wood and a small knot, a lot of them look very similar. And that's how we came to add the brushes into the system, because the robot kept going after and trying to pull small knots because it thought they were nail heads in the wood. And so by taking the rust off that nail head, it no longer looks like a knot, right? It becomes shiny, and that reduced a lot of our false picks. But that's a good one. The other one we have to work on too is after you remove the nail, a lot of times the hole is black. You'll get some staining from the metal on the nail on the wood, and sometimes it's a perfect circle. It looks still like a nail head. And so that requires further training. And so there's all these little nuances that you come across as you start to clean wood. It's like, okay, how do we make the robot smarter so it knows that's not a nail there anymore? It got it, or it wasn't there to begin with. The nail already fell out.
So besides making robots smarter to do the job perfectly, is there any other challenges that you have within your process?
Yeah, so within the process, the key thing for us is throughput. We have to generate large volumes of material in order to compete economically with virgin lumber. Our goal is to drive down the cost of reclaimed lumber to compete with virgin. So we can hire or offer a higher grade product at the same or close to the same price as virgin lumber is our target. And so one of the things you'll notice when the wood comes in, we actually had to build our own rollers. Because nobody's ever moved wood with nails on it in a manner that doesn't result in a grinder. Typically, the material would head to a grinder, and so you just smash the heck out of everything. But we don't want to smash the nails and make the problem harder, and so we actually develop these rollers that allows the nails to pass through without them getting bent over or becoming harder to pick. You'll see there. And so there's a lot of things that we've had to develop and a lot of problems we've had to solve that most people would like, well, why didn't you just use a standard off-the-shelf conveyor belt or a standard conveyor roller? Boards with nails didn't roll so well over those. So we've built a lot of our own technology to solve those problems, transfer and move the material through our lines.
Interesting. So you earlier during the conversation, you touched on reusing concrete, and you saw the opportunities in terms of how we can save these timbers and reuse them for either like building houses and furniture, but your main focus is on building houses with those reclaimed or refurbished timbers. Is there any other material that when you pass the construction site you see the opportunity to reuse them?
Yeah, so right now we're focused on dimensional lumber. The next ones we want to go after are the sheet goods. So think about plywood and oriented strand board, and all those large sheet goods that they use on buildings. How can we reuse those? And then the other one is how do we deconstruct buildings? One of the challenges we still face is demolition contractors love their excavators. It's been the tool of choice for the last X number of years, but it doesn't support reclaiming and recycling very well. Right? It's a very smash it up, sort it all out later, which works great with concrete and steel because those materials are going to get ground down anyways. Right? The concrete slabs get turned into base rock, so they're really downcycled versus recycled, and then the steel gets melted down and turned into new components in its lifespan. And so what we want to do is work on some field tools to help disassemble buildings. And we're hoping a lot of the architecture folks are all thinking about deconstruction and how do we take apart this building at the end of its life. And we'd like to see a lot less glues used because glue is really hard to take apart. That's why I really like, this older timber is typically nails and screw. A lot of nails really is what's holding it together, nails and bolts. Very few screws in this material because they didn't exist 40, 50 years ago and longer. And then, glass partitions. Think about glass curtain walls, right? Could you disassemble the curtain wall off the side of a building and go put it on a new one? I think there's a lot of opportunities to continue to recycle these large components of buildings that can come off with cranes through disassembly or come off with equipment. I think that'd be another good challenge to tackle.
Yeah. While you walking through that process, I was thinking, like, is there any opportunity to reuse the interior of the building as well? Maybe cabinets or like mechanical systems, pipes.
Yeah, casework, absolutely. That's an easy one. There's actually some companies doing that today. There's some reuse organizations that are taking back casework. There's some groups that take it out of healthcare, for example. We've done research on that before this company, looking at how do you reuse medical office building equipment. And so there's some folks doing that. We just need the owners in the AEC community to really step up and say, hey, we're not going to throw all this material away. One of the challenges we have is a lot of contractors want to just get sites clean. They're in this huge rush to get a site clean, and then it sits there empty for months because they're waiting for a permit or they're waiting for materials. And what we really need to do as a community is sit back and say, hey, no, we're going to spend time taking this building apart. We're going to maximize the materials we can reclaim from it, get them to a new home, whether it's in the next new project going in or it's another project down the street. And that should be everything, right? Casework, windows, doors, all these materials that are typically in perfectly good condition. Maybe they just need repainting. Maybe they need a new finish put on them because they're a little worn. And then we need to keep our buildings longer. We need to stop this idea of refreshing interiors every 3 to 5 years and tearing down buildings every 20 to 40 years. It's not sustainable. We need to reuse these structures because they're not falling down. They're not like structurally insignificant or have any issues.
Right.
They don't look modern. And we should be able to refresh these structures and update them without tearing them down. And we just need our owners and architects and contractors to say, hey, let's stop demolishing and let's reuse these valuable resources.
That's a good point, and I think it might be a little bit more common in Europe than the US. So hopefully we'll get there. And
Absolutely.
considering how construction industry is impacting the environment with all these recent natural disasters that we see, the climate change, there is like a huge benefit of reusing materials after demolition and see how we can reduce the impact. And part of the industry is focusing on modular construction. They want to minimize the waste. On the other hand, what we can do, reuse what we already have and making sure that those won't be wasted. Yeah, you want to add something, Eric?
No, I was just agreeing with you. No, it's a great point, right? The prefab, and they almost call it, somebody had a term for it, it's like prefab deconstruction, right? You take the building apart in modules and sections, and then you go reuse it on a new building. There's a couple companies playing around with that as well.
Right. Yeah. Considering what you do is super valuable, not only for our generation, but the future generation, like saving the environment while we can continue building new buildings. How do you think the industry can help Urban Machine to succeed faster in terms of minimizing waste and helping the environment?
Yeah, absolutely. So the biggest thing that we can do is for the architects and engineers is in their specifications, specified deconstruction of buildings. We need to stop the demolition process. It destroys too much valuable material. One of the largest waste companies did a research on what goes into their landfill, and they figured out every year $13 billion worth of valuable material goes into their landfills. And a lot of that comes from construction. And so we really need to take a step back and stop wasting all this resources by just smashing up the buildings and take a look at, should we do adaptive reuse of that structure? Is the first thing, right? Should we just refresh that structure if it is old and worn? And then if we can't do that, how do we deconstruct it and reuse all the materials out of that structure? And so that should be the first conversation every owner, every architect, and their engineers have on a project, is how do we reuse what we already have? That's the most sustainable material, right? Reusing one that already exists today versus making a new one.
$13 billion of waste, that's crazy. And the majority of it from construction. It's wow, we should take an action and making sure that we'll do better than what it is today.
Absolutely. Yep.
And Eric, we're getting closer to the end of our conversation. I really enjoyed learning more about Urban Machine, and I really want to visit your factory one day, whenever it's possible. And how people can get in, our audience can get in touch with you if they're interested, like to use your technology or even learning more about what you do, and or they want to help you with anything.
Yeah, absolutely. So hit up our website, urbanmachine.build. You'll find a link to it on our YouTube channel as well. But reach out to us. My email is eric@urbanmachine.build. Shoot me a note and let's chat about it. If you got upcoming projects, the thing with AEC is the building life cycle of building a new building, right? Design phase, permitting is a long cycle. So we like to get engaged early in that deconstruction and adaptive reuse planning with you. And how do we reclaim the material to maximize the yield? So reach out to us early, right? Let's chat when you guys are planning projects and programs. Let's update those specs. So when that building does finally go to construction in 2 to 5 years, the team's ready to go. You can maximize the materials. You can reuse those materials in your new building and really reduce the footprint of construction, because unfortunately construction is a massive environmental impact, and we've got to dramatically reduce it. And it's going to take a lot of different methods.
Thank you so much, Eric, for walking us through your process at Urban Machine, and hopefully we can do better in terms of saving an environment, and your company is taking like the biggest step in terms of reusing materials. So look forward to the biggest success here. Thank you so much for joining us.
Awesome. Thank you very much for
Yeah,
having me, Simona. It's been a pleasure.
absolutely. Thank you. Take care.